Hello class, this is just another application of determining the term number. In this video we'll be doing the exact same concept in geometric progressions. So here are the two examples that we'll be covering. You can pause the video and give this a go yourself. So here we go. So given the GP, half, 3/4, 9/8, etc., what term number is 6561 over 512? As before, we need some expression for Tn. To find Tn for a geometric progression, in case you've forgotten, is a r to the power of n minus 1. So we can easily see that a is half. Common ratio is not as easy. It's 3 over 4 divided by a half. This one, I'm just going to use my physical calculator here, it's a lot faster. So 3 over 4 divided by a half, I'm getting 3 over 2, or you can say r is equal to 1.5. For this, because the number is in a fraction, I'm going to leave it as a fraction myself. So now that we have this, we have the expression Tn equals half 3 over 2 to the power of n minus 1. Well, we're being told that this is part of the geometric progression, so we can let this equal what we are looking for. So 6561 over 512. Here's where it gets rather tricky, because you can do this in one of two ways. I'm going to go what I believe to be the most straightforward. I'm going to multiply by 2 to get rid of this half. We're left with this weird fraction. Straight into my calculator, 6561 over 512, and I'm multiplying all of this by 2. This gives us 6561 over 256. Here's where some log laws will apply. I'm going to take the natural log on both sides, so ln of 3 over 2. The power becomes the coefficient, and I take the ln of the right hand side as well. Dividing by ln 3 over 2, so we're left with n minus 1 equals, okay, here's where it gets really tight, so I'm just going to move this on this side here. So I'm dividing by this, so I'm moving this as a denominator. So it'll become ln 6561 over 256 divided by ln 3 over 2. And all of this, to leave n as the subject, we add 1. So n equals, just going to copy this, plus 1. Okay, just so I can demonstrate to you what you should be typing in, let me try and type all of this in. 6561 over 256 all over ln 1.5 is 3 over 2 plus 1. Let's hope this inputs correctly. There we go. So this is ln, all of this is equal to 8.98. So n is approximately, well, not approximately, is 8.98, which, as you can probably tell, we need to round to the nearest whole number. So we say that's the 9th term. So the 9th term is equal to this one. And you can test this by substituting 9 back into our formula here. So let's try this out. T of 9 equals half 3 over 2, 9, take away 1. Power of 8. There it is, 656, 1 over 512. Alright, so let's move on to the next question. Hope that kind of gave you an idea. There's going to be log laws whenever we do geometric progressions. So let's give this one a go. Find the formula for the nth term for 2, 6, 18, etc. And what term is greater than 1 million? Well, to find the nth term, we need a. That's just 2. R, I can see it's just times 3. That one I can do without the formula. So n is 3. So t n equals 2 outside of 3 to the power of n minus 1. Now it's saying which number is greater than 1 million. So we're going to take the expression for t of n and let that be greater than 1 million. You can probably tell by now we're gonna take the log of we're gonna divide by 2 first. We're gonna eliminate this constant. 3 to the power of n minus 1 is greater than 500,000 because we divided by the 2. Take the log of both sides. It'll be ln of 3. The power becomes the coefficient, and you take the log of 500,000 as well. Divide by ln3. Just duplicate this, a lot easier. So ln 500,000 all over ln3, adding the 1. Just duplicate everything. Let's see what we get. ln 500,000 all over ln of 3 plus 1. Oop, we get cos. There we go. ln 500,000 over ln 3 plus 1. We get n is greater than 12.9, etc. Well, I hope you can understand that if we pick the 12th term, it won't be greater than 1 million. We can't pick the 12.9 term, so we just say n. Well, if it's going to be greater than this, the first term that's greater than this is the 13th term is greater than 1 million. And that there is our answer. So, hope that gave you an insight into finding the term number and some applications for this process. Hope to see you in the next video. Best of luck.